Hi, this is Discrete Math, Lesson 7.4, Game Theory, Part 1. What we're going to do in this section is look at some different games and see what kind of payoffs that we end up and see if there's determined strategies that are the best strategies for each player in a two-player game. And this gets extended into many situations that are real world, etc. And so we're going to try to look at this. So let's start with a game. If we have two players with a coin each, where they each play for a heads or a tail, or play a heads or tails. Tina and Saul will play with the following payoffs. If both coins come up heads, then Saul wins $3. Now we're not flipping these coins, but they choose which head or tail they want. And then if both coins come up tails, then Tina wins $2. If both coins are different, then Tina wins $1. So what we want to do is try to set this up into a game matrix. And so we look at this. This is the game matrix that would satisfy these conditions. So but now you look at this, this is from Saul's perspective. It is not Tina's perspective, it is Saul's perspective. So if both coins come up heads, then Saul's going to win $3. If one comes up heads and one comes up tails, then Saul is going to lose $1. And then the last case would be right here. If they both come up tails, then Tina is going to win $2. Now what we want to try to do is figure out if there is a determined strategy that will come about over the course of time. What does Saul want to play most of the time? What does Tina want to play most of the time? Now, not always will it be a single strategy, and we'll get into that more in Game Theory Part 2, but we want to look at to see if there is a determined situation for this one right here. So if we look at this a little bit, let's look from Saul's perspective. If he plays heads, he can either win 3 or lose 1. If he plays tails, he can lose 1 or lose 2. Well, what is he going to do? Well, it makes most sense that he would play heads most often. In fact, probably play heads all the time, because why would you want to lose? Here, the worst case scenario is that he loses $1. Here, the worst case scenario is he loses $2. His best case is losing $1. So yes, he'll probably play heads all the time. What about Tina? Now remember, these numbers are with respect to Saul. So in this one, she's going to lose $3 or she's going to gain $1. And here, either she's going to gain $1 or gain $2. What do you think she's going to do? Well, I'm going to guess that she's going to play tails most often, if not all the time, because her worst case scenario is winning $1. Does that make sense? Okay, so what we want to try to do is figure out what strategy each person will use under that. Before we do that, though, let's write this from Tina's perspective. This would be a matrix set up from Tina's perspective. So in your mind, you either have to think like this, or when you write your matrices, you have to put Tina's in next to each one of these values so that you can figure out in your mind what is happening to Tina. Or this might be player 2 and this might be player 1, whatever the case might be. But this is the payoff matrix from Tina's perspective. Okay? So there is a strategy called the maxi-min and mini-max strategy that we want to try to look at. So if I have the matrix here from Saul's perspective, what I want to do is look at Saul's worst case scenario, which would be the minimum value here. So I look at this and I would write the minimum value, or what I call the worst case scenario. And then I look here, and what's the worst case scenario for Saul here? Well, that would be -2. Now what we want to do is try to figure out the best of those two, because then I can determine if I'm going to play heads or if I'm going to play tails. The best of these two from Saul's perspective would be the -1. So what we did was we took the minimum of the row, and then we took the maximum of those two values. Yes, -1 is a maximum over -2. So all you have to do really, worst case scenario, and find the highest one. Now we want to do the other one with Tina's perspective. In the column now, what is the worst case scenario for Tina? Now you got to remember that these are the actual numbers for Tina. So you got to think in your head or rewrite. You decide how you want to do this. What's the worst case scenario for Tina? And I'm going to write the 3. That would be the worst case scenario for her. Now, this would be gaining $1, and this would be gaining $2. What's the worst case scenario for her there? This would be a -1. Now, what is the minimum of these maximums? And that's what we're doing now. We take the maximum, and we're going to find the minimum of these. Or you could say that's the worst case scenario for Tina, worst case scenario for Tina. And then we want to find out what is the minimum of those two values, which is actually the maximum value for Tina. Now, if these two values are the exact same one, they both come from this -1 right here. If they both come from that same value, we have a determined situation. And this is called the saddle point. And if it's the same, your strategy is going to come out for Saul playing heads, and this is going to be Tina for playing tails. So since we have this saddle point where both of these match up, then we have what we call a strictly determined strategy. And that's where the maxi-min, the maximum of the row minimums, and the mini-max, the minimum of the column maximums, is the same value. This value is called the saddle point and can be interpreted as the amount won by the player per play by the row player. So this is the strategy that comes out, and what this number means, this -1, means that on average, or what else we can say, is that every time he's going to lose $1. That's the payoff. So Saul loses $1. Every single time. Okay? Now this isn't very interesting, but these situations do happen. And they might, on the surface, seem like lots of different things are going to happen, but this situation might come up where it is strictly determined anyways, and you'll find out when you play for a little bit. All right? If it's not strictly determined, like I said, we're going to find out in part 2 what will happen if it's not strictly determined. Now, this mini-max, maxi-min, this all can get a little confusing. If you keep it in very simple terms, though, I think it works out. Worst case scenario for Saul, find it. Worst case scenario for Saul, find it. Worst case scenario for Tina, find it. Worst case scenario for Tina, find it. You're going to take the maximum of these numbers, the minimum of these numbers. That's all you're going to do. So don't overwork all this terminology. Just do it that way and you should be okay. If they turn out to be the same value, then we have strictly determined. If we go down here, then in class, what I want you to try to do is to play these games against each other. Now, if you notice, worst case scenario here is -1, worst case scenario here is -1, -1, -1. Since they're all kind of the same, we probably don't have a strictly determined situation. And so you're going to have to play this one out to see how this one works. Similarly with this one, this would be -3, -3, worst case scenarios. This one, the worst case scenario here is losing 1, and here would be losing 5. And so this one might be, I guess it's not strictly determined either. So you'll have to play these ones out to figure out what happens with those. In this book, in this section, most of these problems will be strictly determined. So you'll just have to figure that out. And then obviously we'll extend this from a 2x2 matrix to a 3x3 and so on. It shouldn't get too tricky for you, but test it out. All right, I hope that this helps for you, and I hope you have a great day and try this homework and get it going. Thanks very much. Bye.